Hello, everyone. I'm Dr. Christian Furman, Medical Director for the University of Louisville Traeger Institute and Republic Bank Foundation Optimal Aging Clinic. I hope everyone enjoyed the beginning of the conference. I've enjoyed the conference thus far, particularly our opening session presenter, Dr. Melissa Sunderman, DO, Doctor of the Outdoors. Now I'd like to welcome you to our second general session of the day. We're glad you're here with us in this virtual environment for our 2023 Optimal Aging Conference. Want to take time to let our sponsors and exhibitors know how much we appreciate their support. Please make sure you visit the virtual exhibit hall to learn more about these amazing organizations. As we prepare to hear our keynote speaker today, we have welcome remarks from the Dean of the University of Louisville School of Medicine, Dr. Tony Gansel. Then Mary Lynn Spalding, CEO of Christian Care Communities, will speak. And finally, Jennifer Craig, Director of Kentucky's Office of Dementia Services. First, Dean Gansel.
Well, greetings. I'm Tony Gansel, Dean of the School of Medicine and Vice President for Academic Medical Affairs, and it is my pleasure to welcome you to the 7th Annual Optimal Aging Conference and our 4th year as a virtual event. The theme for this year is caring for the mind, body, and soul, because we know that all of those are incredibly important for the health of our seniors. We'll be spotlighting work of those in the gerontology and geriatric fields who advocate and actively work on policies and services and resources that support aging in place. And we want to showcase our older adults who have remained active and flourishing even amid a pandemic. You're going to hear from leaders in the field, in the aging field, and octogenarians from the community, holistic practitioners, and many more as they share stories about how to inspire and innovate, how to impact, how to investigate, and how to integrate health and aging experience. We're going to feature experts in aging and dementia and Alzheimer's research, public health experts, all focusing on how aging can actually inspire us to achieve our best. You'll hear from professionals and older adults on a range of topics: mental health, technology, ageism, and active engagement and holistic interventions. So lots of exciting topics, general sessions that are going to include conversations with Anna Fall, who is our Executive Director of the Traeger Institute, Dr. Melissa Sunderman, to talk about benefits of movement in nature, Dr. Gregory Jicha providing updates on Alzheimer's research, Dr. Kim Williams to talk to us about nutrition and health equity, and Sandy Markwood and Bob Blancato, who advocate for policies to improve home and community-based aging services. We're excited about this conference and what the conference and the Traeger Institute can do to share the work that's going on to improve the health of our seniors and to improve the health of our community. We hope you enjoy the conference, and welcome.
It's a real honor to be with you today at the 2023 Optimal Aging Conference. I'm Mary Lynn Spalding, President and CEO of Christian Care Communities. For 139 years, Christian Care has been serving seniors in Kentucky, and we've grown to become Kentucky's largest nonprofit, faith-inspired provider of affordable senior housing, skilled nursing, long-term care, assisted living, memory care, and home and community-based services. It's a joy for Christian Care to sponsor this very valuable conference, as it brings the best and the brightest in healthcare together to support aging as an opportunity to inspire, innovate, impact, and positively integrate the aging experience into each of our lives and families. When I saw Dr. Jicha was leading this next session, I wanted to be a part of this time together because I greatly respect his background, research, and insights into the very difficult journey of Alzheimer's disease. I come around this topic from so many different perspectives. The first perspective being my own mother, who had Alzheimer's disease. Our family walked alongside her for over 10 years. The second perspective is, of course, my work at Christian Care, where we minister daily to hundreds in our care across the state who have some form of dementia or Alzheimer's disease. From our specialized memory care units to the Best Friends Adult Day Centers, caring for all our residents, staff, and families is the highest priority to me, but especially in memory care as it hits home. Finally, most all of you have heard our dear friend in innovative dementia care, Virginia Bell, passed Easter weekend. She was in hospice care the last few weeks of her life, but even in her bed and in discomfort, she was making videos expressing her gratitude to the researchers, the scientists, the medical professionals, and businesses who had adopted dementia-friendly access for families, all in support of the Best Friends approach to dementia care. I had the pleasure of working closely with Virginia, a wonderful mentor and a true best friend. So you can see why this session means so much to me and how much I appreciate the fine work of Dr. Jicha and the research teams around the world who are working tirelessly to end this disease. Dr. Jicha, thank you for your life's work and for your steadfast commitment to enhancing the lives of those with Alzheimer's and dementia.
Good afternoon, and welcome to the second general session of the 2023 Optimal Aging Conference. My name is Jennifer Craig, and I am the Director of Kentucky's Office of Dementia Services. I am honored to be here with you today and share with you just some of the ways that Kentucky is helping individuals with dementia and their caregivers to care for their minds, bodies, and souls. It is with great pleasure that I have the honor to introduce a dementia leader in Kentucky and our next keynote speaker, Dr. Gregory Jicha. Dr. Jicha is a professor in the Department of Neurology at Sanders Brown on Aging at the University of Kentucky. He shows his passion for Alzheimer's and dementia not only in the classroom, but also by leading numerous Alzheimer's and dementia committees and associations, and continues the much needed research. Thank you, Dr. Jicha, for being here and sharing your knowledge and expertise.
There we go. Well, I'm delighted to be here today with you all, and I'm just going to try to pop up my slides. I have something that I think is really just so timely and interesting for us to talk about today that I hope it brings insights to you and some real clarity. So we are going to talk about advances in Alzheimer's and dementia research, and I'm really going to take this keynote time to help us to understand the emergence of these anti-amyloid therapies that we've heard so much about. So I do have some disclosures. I included some past ones as well. Nothing relevant for all intents and purposes, other than I've been active in the field of contract research with several pharmaceutical companies that have led to where we are currently in the field. So our learning objectives really, for all intents and purposes, we're going to focus on that funnel that you see to the far right. At 10,000 compounds enter drug discovery, and one hopefully drips out the bottom. This is painfully slow, but we're working at it. So we've all been excited over the last 2 years to see the first disease-modifying therapy start to come up for FDA approval. But really what we're going to focus on today is this timeline of anti-amyloid therapeutic discoveries dating back 25 years now, really decades of work. And we'll walk all the way up so that we understand the current approvals and status of these medicines. So why amyloid is a target for drug development? Well, we know that this is a protein that we're all making, believe it or not, no matter how good we're doing at any given time. Usually we're clearing it as fast as we make it. But in Alzheimer's disease, as aging progresses, this starts to build up, aggregate into toxic forms, and injure the brain. And we know that all the autosomal dominant genetic mutations work by increasing amyloid production, and that this is really the first step in the development of Alzheimer's disease. So let's go back in time to 1998 and start with the AN1792 vaccination program. So many people don't realize that, yes, we had a vaccine for Alzheimer's in 1998. And on the far left, you can see the animal studies showed this to be a huge success. It worked to eliminate Alzheimer amyloid plaques from mouse brains. And then human trials were started. And it did indeed seem to reduce plaques in the brain of many, many individuals if they showed an antibody response. And if we look at just those humans that showed an antibody response, it led to a 23% slowing of cognitive decline. But unfortunately, the trial had to be stopped for safety concerns. So we learned some lessons, and that's the whole a part of science that allows us to grow, is that active vaccination cannot be controlled precisely. So when some of these individuals developed inflammation of the brain, we were unable to stop it. And so we needed to gain better control. We also learned that the amyloid kind of moved from the plaques into the blood vessels before it was eventually cleared. And so this pushed us towards passive immunization. Very, very important. So we can continue that journey. It took us several years to get back. Now, what's passive immunization? Well, instead of a vaccine that has the body produce the antibodies, in passive vaccination, we give the antibodies through an injection or an infusion. And so that journey really began back in 2006. And all the way along, we've been a very strong part of this discovery here in Kentucky. So this passive antibody was exactly the same anti-amyloid target as AN1792, but we could start, stop, adjust dose. The animal studies on the far left were positive, clearing the amyloid out with injections, and so the human studies were begun. And the human studies did indeed show a signal for benefit. A subset that had amyloid PET in green to the right with red is amyloid PET imaging showing that those that received the treatment in the top panels before and after, two patients here, that we could essentially clean the amyloid out of the brain, as opposed to the bottom panels where the amyloid slowly increased. We did once again, though, see some edema, inflammation, swelling of the brain, and bleeding, similar to that seen with AN1792, the vaccine. So this seems to be something that we really need to watch. So we learned some additional lessons. We learned that passive immunization can remove A beta from human brains. It wasn't shown in every patient because not all of them had PET scans, but it clearly was demonstrated in 2009. The removal of A beta is associated with a slowing of decline in cognition, albeit the study was not successful in all of its endpoints, and that edema and bleeding remains a problem. And that's associated with both the dose and a person's ApoE status. So we need to be very careful, even with passive immunization that we can control. We need to take ApoE status into consideration, dose into consideration for everyone. So it taught us a lesson, and the lesson was the birth of what we call ARIA, amyloid-related imaging abnormalities. And that comes as an E form, edema, or an H form, hemorrhage in the brain. And this is very, very similar to what we see naturally in many Alzheimer patients with cerebral amyloid angiopathy. The Alzheimer amyloid in the blood vessels and it can be associated with spontaneous inflammation of the brain. This has been well described, and you'll see that on the left side of the screen. So in 2011, a group of experts got together and coined the term ARIA. I was fortunate to be part of that meeting and to really begin to understand this process. We're still not clear, and the cartoon diagrams suggest a variety of different ways that this might work, with antibodies infiltrating the blood vessel, or amyloid becoming disruptive or accumulating even worse in the blood vessels, and or inflammatory cells attracted by the antibody amyloid mix. We're still trying to tease that out. We've also begun to learn that, well, we don't just have to target that same piece of amyloid that the AN1792 antibody targeted. We can target other forms of A beta. So we know that amyloid, when produced, lives by itself as a monomer. It then begins to aggregate and form soluble oligomers, and these then clump together to form plaques. So it might be that we need to remove monomers, or maybe just oligomers, or maybe plaques. So this gave rise to a host of second-generation antibodies. And so let's continue the journey with solanezumab in 2007. This is an antibody that targets just the monomers. It won't see the plaques or the oligomers. And this was really what we call the sink hypothesis. Remove that building block for amyloid plaques, and we'll stop the disease from building up in the future. And so the solanezumab studies were done and published eventually in 2014, New England Journal of Medicine. Didn't quite hit the mark in terms of its p-values, but overall what we could see was about a 29% slowing of cognitive decline, similar to what we saw with bapineuzumab. And in terms of ARIA, we saw that it was very, very safe, very, very, very similar to the placebo group across the board. So maybe a safer way forward with about 30% reduction. So we learned several different lessons. One of the things we learned from solanezumab was that targeting just monomeric amyloid does not reduce plaque levels. So the plaques remained in these patients' brains. And that's okay. If there is a clinical benefit, that's wonderful. It is a very safe medication as well. So other medications coming out, crenezumab, I was very excited about this in 2012, targeting just the soluble amyloid oligomers. And so this may be the most toxic form of amyloid. And I really had high hopes for this, but the results when they came out were absolutely negative. So in the middle panel, we can see no difference in cognition and change in cognition between placebo and the antibody treated group. But also, we didn't really see a change in amyloid, perhaps a trend towards slight lowering as we saw with solanezumab, but really overlapping with the placebo group. So both phase 3 studies were just stopped for negative efficacy. Interestingly, ARIA, like with solanezumab that didn't touch the plaques, was exactly the same for the placebo and treated patients in the study. So there must be something about ARIA that has to do with the fibular amyloid in plaques. So these crenezumab lessons are very, very important. Two possible explanations. One, the antibody didn't work. It didn't capture oligomeric A beta, or that oligomeric A beta toxicity has little to do with progression. And as we can see here, when we look at oligomer assays in the treated patients, we basically say no, that the crenezumab didn't significantly change the oligomers from that seen in placebo. So maybe targeting oligomers may still help, but crenezumab, even though it could do it in the laboratory, could not do it in living humans. So let's continue the journey with gantenerumab in 2017. Now, this is an antibody that targets not just the soluble oligomers, we think, but really a focus in on the plaques, just like bapineuzumab from 2006. And, there were many positive things about this antibody. It was a subcutaneous injection rather than an infusion. And the preliminary studies showed great removal of amyloid and suggestion of efficacy. Now, these results were just released December of this last year, so we're really getting into the present day and age with many of these. No statistically significant benefit was seen. So really disappointing. But when we looked at the amyloid reduction in the brain, it was only about 50% of what was expected. It only half cleaned the amyloid out of the brain. And so it remains unclear whether or not, if we had given higher doses or if we had continued for a longer period of time, might we have seen benefit? Again, we could see a dose-dependent increase in ARIA, the edema and the hemorrhage in the brain, with ApoE status, and again with dose, limiting some of what we can do. So we began to see, really just this year, if any of these anti-amyloid approaches are going to be successful, they have to remove amyloid plaques. And the more plaque they remove, the more benefit we're likely to see clinically. It also showed us for the first time that safety appeared somewhat dissociable from amyloid removal effectiveness, because here's an agent that was poorly effective in removing the amyloid plaques, could only get rid of about half of them, and yet its ARIA rates were as high as some of the others we've seen in the past, such as with bapineuzumab. So very, very important. Fortunately, it did teach us as well that subcutaneous delivery of the antibodies, an injection somebody could give at home like a diabetic with their insulin, can be just as effective as infusions in infusion centers. So this may be helpful. And again, even though these studies have not shown us to this point the positive benefits that we're seeing, each study was a success in that it taught us important lessons moving forward. So let's continue the journey with aducanumab in 2017. This really has the same target as the initial vaccine, AN1792, and bapineuzumab. It really seems to target the plaques predominantly. And that's important. So 2 studies were done, the Engage and Emerge study, testing aducanumab in 1,600 mild AD patients. And they were able to definitively show, as we can see in the colored brain scans at the bottom, the drug removed amyloid plaques from the brain. Virtually 100% could clean the amyloid plaques out of an Alzheimer brain. And very, very important. But the Engage and the Emerge had different outcomes clinically. One showed a positive benefit and the other showed no benefit. And so the FDA concluded that, well, we really don't know if it's going to have clinical benefits or not, sent them back to do another study. Of note, again, we see ARIA, 41% of subjects with brain swelling, stroke, or bleeding in the brain, and many of those actually with symptoms that included worsening of the cognitive decline we were trying to treat. So this caused a lot of controversy. And those of you that can remember back a year and a half ago, not quite 2 years ago, this FDA accelerated approval was given in June of 2021. There was a lot of debate in the field with, the FDA under scrutiny and people arguing in the scientific community. We learned lessons from the aducanumab studies, lessons learned 2021. This finally was really definitive proof that we can fully remove amyloid from the brain of patients with Alzheimer's. We administer these antibodies and boom, and both studies definitively showed, yes, we can remove the amyloid. Clinically, though, with one positive and one negative study, we still don't know what that benefit might be. So the FDA said, we'll give you accelerated approval, but that approval is conditional on doing another study. And that's where we left the field a little over a year ago at the start of 2022. So what does that mean? Well, we need to understand that. What's accelerated FDA approval? Well, accelerated approval means the FDA knows how much we need this, knows that Alzheimer's is an unmet need, and that this is an important need for new medicines that can actually change the disease itself. And so the accelerated approval was granted on the basis of the medicine clearly removes amyloid. We think that that is likely to be important in slowing the disease, but we just haven't shown that yet. So that's where the accelerated approval came in, removes amyloid from the brain. The conditional approval is go out and show us that it matters clinically to the patient, that it's going to help them in some way. And so with that conditional approval, for all intents and purposes, aducanumab remains an experimental research drug, similar to the many others we're working with in the field. So what does it take for full FDA approval? Full FDA approval means show us the clinical benefit. And really, that is the push right now for all of these antibodies to obtain full FDA approval. So let's continue the journey with yet another antibody, donanemab. This was developed by Lilly, and it targets a specific type of amyloid, what we call pyroglutamate amyloid. So this is a very toxic species of amyloid where pyroglutamate is added to the amyloid molecule. This greatly increases plaque deposition, inflammation around those plaques, and toxicity in the brain. And so the donanemab antibody targets this highly toxic form of amyloid specifically. And so the phase 2 data has come out, and that's what I'm showing you here, published in the New England Journal of Medicine in 2021, showing to the far right amyloid plaque removal, complete removal from the brain as opposed to the placebo group. And for many, complete removal within 6 months of receiving the medicine. So that quick to get the amyloid out of the brain. And indeed, the clinical benefit was seen as early as 36 weeks out, persisting through 76 weeks, about a 32% reduction in the decline seen in Alzheimer's. So it didn't, like the other antibodies we've seen, slowing it 23, 27, 30, 32%, right in that range of about 30% slowing. associated with complete removal of the plaques. ARIA risk, however, remains quite high. Very, very important, those lessons learned back in AN 1792 and with bapineuzumab, teaching us again, we really need to watch these antibodies. So we learned some lessons here. We learned that a clinical benefit of 32% is probably about all that we are going to see with removal of amyloid from the brain. That ARIA rate needs to be taken into account. And so Lilly went to the FDA and said, hey, we showed that we remove amyloid from the brain. Please give us accelerated approval as well. And just about 2 months ago, the FDA came back and said, nope, we're not going to give you your accelerated approval. And many people don't understand that. Well, what they did in the donanemab study was if people had completely cleaned the amyloid out of their brain by 6 months, they stopped taking the drug, and that was considered the end of the study for them. So the FDA said, well, not enough people received the drug for 52 weeks or 76 weeks for us to know what that benefit was. I'm not sure that I fully understand that decision, but donanemab is one of the antibodies that's not been given accelerated approval. So up to this point, we have aducanumab with accelerated approval, but conditional approval, go back and do another research study. Donanemab is well underway with their phase 3 study. We expect those results in about a month, the phase 3 donanemab, and they're not going to make the same mistake again. They're going for clinical benefit demonstrated again for a second time and full approval. We'll see how this plays out, but there's a lot of potential here for donanemab to apply and by the end of the year perhaps receive full approval if their phase 3 trial is successful. So let's continue the journey with kind of the new kid on the block, lecanemab. So this takes us back really to 2012. This is an antibody again, like gantenerumab, that targets soluble oligomers as well as the plaques. And so a phase 2 study was started at that time. We were part of it. We have dozens of people here in Kentucky that received this medicine and completely cleaned the amyloid out of their brain. And that's really amazing. There were several different doses in the phase 2, and you can see those in the colored graph to the bottom left. And we saw the most amyloid clearance in the group that received the highest dose of 10 milligrams every other week. Initially, the trial ended and everybody was told, nope, it doesn't look like it's positive. So they stopped and began hashing their data. And then about 6 months into that, they realized, we made a mistake. The study was really positive. So they reinitiated what was called an open label extension. And I still have people from that study in 2012, 11 years later, on this medicine currently. What we saw, very interesting, in that gap period, right? The trial ended, and then there was a period of time, 6 months to 2 years, depending on the individual person where they were in the study, where they did not receive the antibody, and their Alzheimer's was allowed to just do whatever it would do after clearing the amyloid out of the brain. And so these bottom 3 graphs are very, very telling for us. Panel A shows a very slow increase in that gap period. So the amyloid, getting rid of it doesn't mean it's not going to come back again, but it does kind of reset us at baseline. What we saw in panels E and F to the right on the clinical outcome measures was that treatment separated the groups, and then afterwards, stopping the treatment led clinical progression to continue, but in parallel. This taught us that this is not a symptomatic effect. If it was a symptomatic effect, stopping the medicine, the two groups would have come back together and been the same. Thus, treating with amyloid actually changes the disease course permanently. So with that excitement, they went into the lecanemab phase 3, and these were released last December 5th in San Francisco. I was there, as were many others, and many of us watched this unfold in the media. Positive phase 3 results, again, clearly demonstrating a clinical benefit, a slowing on their primary outcome measure shown here, CDR sum of boxes, the clinical dementia rating scale, of about 27%. We do still see some ARIA, but it's low in the 12 to 14% range with lecanemab. And, they really did such a good job. So on this panel, in the upper left graph, you see the removal of amyloid from the brain, complete removal. And so lecanemab was given accelerated approval. You convince the FDA that you can remove amyloid from the brain, but not just the clinical dementia rating scale, other clinical outcome measures, the secondary measures, the ADAS-Cog, which is tests of memory and thinking, the ADCOMS, which is another composite memory and thinking measure, and the MCI activities of daily living score scales, all statistically improved or slowed the delay associated with not receiving these medicines. And that effect was as high as 40% for preservation of ADL. So people on these medicines are still getting worse over time. We're slowing things down. So with this data in hand, on February 6th, when lecanemab was given accelerated approval by the FDA, Eisai turned around and immediately on January 7th, reapplied to the FDA for full approval. We're expecting an FDA decision in early June of this year. So again, a month and a half away, perhaps, for the first full approval. The experts in the field, unlike the history with aducanumab, where the field was torn over should this go forward, should this not go forward, the field is really universally behind lecanemab right now, and there's full expectation that it will gain FDA approval. The VA announced a little over 2 weeks ago, even before FDA approval, that they believe the data and they are going to pay for and provide lecanemab to all veterans. And so this is well underway to becoming the first mainstream disease-modifying therapy. So we learned some additional lessons here. We learned that the clarity, the phase 3 data, is really the most definitive evidence of clinical benefit that we've seen to date. And that benefit ranges about 30%, anywhere from 27 to 40, based on what your outcome you're using. Interesting, similar to the many other amyloid removing antibodies that we see out there, and that ARIA rates appear relatively low. So again, suggesting that we can dissociate, at least to some degree, safety from amyloid removal and safety from clinical efficacy. Not perfectly, but moving in that direction. So again, FDA full approval. This is what it's going to take to move Alzheimer's forward. This is where we are currently. What does that mean? Well, that means it's based on phase 3 data, right? So phase 1 studies, first in human, safety only, not even with a targeted population. These antibodies were tested first in 20, 30-year-old healthy adults. Once they showed that they were safe, relatively safe, they moved to phase 2. Phase 2 looked for dose. What's the right dose? And do we get a signal for effect? And then phase 3 is proof that we actually have a clinical benefit. And so this is where we are currently. 2 independent studies. Lecanemab has it. Donanemab, if their phase 3 is positive, we'll have 2 in another month. So we're starting to see this move forward. Now, we also know that there's a possibility for surrogate endpoints. What's a surrogate endpoint? Well, similar to the accelerated approval by the FDA, right? So we use a surrogate endpoint for antihypertensives. We measure your blood pressure, and if your blood pressure is better on the medicine, then we say, yes, you're an approved antihypertensive. You don't have to follow people for 5 years, 10 years, waiting to see if that reduces their risk for heart attack and stroke and other negative consequences of hypertension. So there's some debate in the field right now as to whether or not amyloid removal should now be considered a surrogate endpoint for AD, and that we should no longer worry about whether or not clinical benefit is proven. This is a hot topic debate in the field currently. Right now, we still do want to see a clinical benefit because we've seen several of these medicines dating back to 2006 with papanuzumab that can remove amyloid from the brain. And yet, for many of these, the risks were too high, counterbalancing benefits, or the benefits were not seen. We need to see both. And so that FDA approval coming forward really is as quick as the field could move. Each antibody learning from the one before it, moving ever steadily closer towards new medications. Now, the other debate in the field that you might read about in the news is, well, is this meaningful clinically? Well, people are still getting worse. Is it meaningful? And the field really has gathered around the fact that, yes, we believe this is clinically meaningful. So this is a scientific review and commentary from Alzheimer's and Dementia from some major names in the field, all very good friends of mine, looking at what does it mean if we have a 25% slowing of progression, let alone a 40% slowing of progression. It means that the longer you potentially use the medicine, the more that benefit is going to magnify. And so over the 18 months of the lecanemab study, what we see is about a 7-month benefit. So keeping people where they are for about 7 months longer than they would have otherwise. And that benefit, if extended over several years, could amount to years and years, 4 years potentially or more, of stabilizing the disease at the early stage. And we know that Alzheimer's is a fatal disease. It's a killer. And we still treat incurable cancers to buy people additional time, additional quality of life. And Alzheimer's really should be no different. So I believe buying somebody 7 months, buying them a year, buying them 2 years is incredibly beneficial. So we've learned many different things as we've walked through history. Are the medicines all the same or are they different? Well, there's a little diagram in the upper left showing you the different antibodies and where on the amyloid molecule they actually bind. We can see that they're different. We could see below that risk of ARIA differ significantly amongst the different antibodies. So we have to look for safety here. And then on the right, we see that association. On the x-axis, amyloid PET. The lower we go over there, minus 90, complete, minus 80, minus 90, complete removal of amyloid from the brain. And that is really what slows the progression of disease. So the risks differ amongst these antibodies and the benefits differ between these antibodies. They are not all the same. And we need to be very, very careful as we move into this next era of disease modifying therapies to make sure we're using the right antibodies for the right patient in front of us. Now, the other issue that's really come about in the field is this question: why only 30%? We've completely removed the amyloid. Why don't we get 100% benefit? Why don't we just stop Alzheimer's disease? And there's really two possibilities. One is we're treating far too late in the disease. Tangles have already started up. The brain is already malfunctioning. So maybe we need to treat much, much earlier. Or maybe there's just so many different disease processes going on that we're going to need more medications. So very, very important. So the final piece of data just came out a little over a month ago is solanezumab, the monomeric antibody, which in 2011 was taken back to what we call the A4 study. Treat people who are still cognitively normal, but we know that they already have a buildup of amyloid in the brain, preclinical Alzheimer's disease. And that data was just released a little over a month ago. Unfortunately, a negative study. Solanezumab could slow the buildup of amyloid plaques, but could not stop it and could not remove the plaques from the brain, as we saw in the solanezumab studies from 2007. And that there was no benefit on the clinical outcome measures. So moving earlier may not work unless we actually can remove the amyloid from the brain, as we've learned from the other studies. And so over the last year or so, we've been working on a major national project called the AHEAD study. We are using the lecanemab that we know can completely remove the amyloid from the brain in people who are still clinically normal, but have that early buildup of amyloid pushing them towards Alzheimer's in the future. This is called the AHEAD study. It has sites across the United States and really across the globe. That other fundamental question, we have this overlap. It's not just Alzheimer's, but maybe it's Alzheimer's with vascular disease or TDP-43 or Lewy body disease. Maybe we need to also remove the amyloid, but also target tau and tangles, target Lewy bodies, target TDP-43, target vascular disease. And so this is really going to be the topic that I'm going to discuss in the breakout session. Where are we with all of these other approaches? To sum up, though, there are some imminent practical issues moving forward that we should all know. These medicines are coming. We expect full FDA approval in June. If you work at the VA, you can already prescribe this and have it paid for your patients with MCI and mild Alzheimer's disease. Critically important, not for people with moderate or severe Alzheimer's. The patient must be able to have an MRI scan. So any of those veterans with shrapnel or pacemakers that can't have an MRI, we're not going to be able to monitor them for ARIA. They can't have the medicine. Patients that have had significant past microhemorrhages or bleeding can't have the medicine. We need to be concerned about those on blood thinners, Coumadin, heparin, Xarelto, Apixaban. These are very, very important. There's no concern for aspirin or Plavix or these sorts of agents, but certainly Brilinta, but certainly for folks that are on true blood thinners, we need to be cautious because a microhemorrhage could turn into a disaster. And there have been 3 people that have died from these medicines. 2 of them on blood thinners. We still need to wait for that FDA full approval. And then we do expect that Medicare will pay for it like the VA. So coming, watch this space over the next 4 to 5 months. By the fall, we are in a new era of Alzheimer's disease. Now, what's that impact? Well, I for one am delighted that we've moved forward. We have many patients that have been on lecanemab for over 7 years now. As I said back in 2012, at the start of the lecanemab journey, the first person to be cured of Alzheimer's will be cured in a clinical trial. And so a lot of work to do. 30% is not the 100 that we want to see. We need to do better. And each successive generation of experimental medicines brings us closer to safer and better medicines. Eventually, the cure we're looking for. We should understand that many not eligible for lecanemab may still be eligible for many of our other new experimental treatments that may be even more powerful. And it remains unclear how we'll adapt to combining medicines, but this is where the field is moving. So I'm going to stop there, and I'd just like to sum that up by saying I hope you kind of understand what all the media debate has been, how this has been a process over 25 years to get to the point we are today, and that everyone understands we are entering a new world for the care and treatment of those with MCI and or mild dementia. It's been too long. There's been too much suffering and death. And to be able to slow that by 30%, to me, is a blessing. I'm sick of losing patients. I want to give somebody 7 months. I want to give them 2 years. I'd like to give them 4 years. I want to give them more. Change is finally here. Disease-modifying therapy is here. And I, for one, embrace this new world that we're in today. So I'll take off on Star Trek. We're not quite heading into outer space as of yet, but we'll get there in the future anyway.
Dr. Jicha, that was amazing. I always look forward to your presentation every year because we learn so much. So I'm going to go over just some of the questions that are in the chat. So Justin Magnuson asked, do the names of these drugs point to benefit or mechanism the general public wouldn't understand, or were they created by marketing team? So, I do know, the MAB at the end of these words, the MAB is monoclonal antibody. So that helps people realize they're all the same class, the MAB. But I'm not sure about the first. Does it mean anything? No,
not really. People just get to invent that off of whatever they're most fond of. Anyway, I wish that it made more sense. But
yeah, but that is helpful because I think, Justin, it's good that you pointed out the MAB is monoclonal antibody at the end of it. AB is antibody, M is the monoclonal. So that's perfect. Okay, and then another question here we had in the chat. Let's see. Yeah, Barbara Gordon. Do you have any hope that we'll come up with a pharmacological cure for Alzheimer's in the near future? You kind of answered that. You said somebody in a clinical trial will be the cure. When will that be? What's your prediction?
I think, my personal belief is that why are we only at 30%? I think it's both of those reasons. I think we need to find people earlier and get the disease out of their head before it progresses. But I also think for most people in the community, the people that you and I take care of on a regular basis, they have more than one thing. They're going to need, we don't cure most cancers with a single medicine. We use combination chemotherapy to defeat the cancer. And we don't wait until the cancer stage 4. We get it at stage 1, That's
what there's a lot of similarities, but the thinking about this with cancer, and this kind of leads to Barbara Gordon's second question. What are some non-pharmacological strategies? Because some of these people that have dementia, it's not just all Alzheimer's, it's vascular, there's other things that are playing a piece. So what are the, other strategies to prevent, slow, or treat Alzheimer's?
So we know quite a few of them. In general, we have the very good evidence that control of blood pressure is critically important. That physical exercise, 30 minutes a day, incredibly important, and that cognitive stimulation, incredibly important. There's less clear data, but still pretty convincing in my mind, that diet is incredibly important, that management of other medical conditions, not just hypertension. And I will talk about some of the latest in my breakout session, not just other medicines, but some of what we've learned in the last year about exercise for one. In terms of its potential benefit in slowing the disease. I do think that's the approach. I think a combinatorial approach. Don't expect a medicine in and of itself to fix everything. You can take as much atorvastatin as you want, but if you eat 2 pounds of bacon a day, we're going to have a hard time getting your cholesterol under control.
Yeah, that's so many good examples. Thank you. And Jessica Elkin kind of asked something along those. We talked about the lifestyle issues, but what about environmental factors that play a role in dementia?
Yeah, so lots of environmental factors, and lots of them are being explored. There's been a whole surge in data coming out suggesting that air pollution may be a major contributor to Alzheimer's disease. And so maybe we got to clean up our world to clean up Alzheimer's disease. So lots of work in that space. And certainly the local environment with social engagement. And I think that's some of what we've learned from the exercise studies that I'll discuss at the next breakout session, is that maybe some of that impact has to do with the socialization aspect of the exercise program, in addition to the exercise benefits themselves.
Yeah, and some people, lead has been linked, but it's not Alzheimer's. I think, that's a different type of dementia. So I think the big thing is people have to really make sure they're doing a good screening process to make sure they have a right diagnosis and treat it appropriately. So there's lots of good questions. Another question here from Jennifer Craig is, that the MRIs that are needed to look for this ARIA, for the microhemorrhaging, are physician offices, hospitals, treatment sites, et cetera, ready for this MRIs and the increased number of MRIs? And has Medicare discussed the costs associated with the increased, cost of the beneficiary, the co-pays? Are going to pay a co-pay every time they get an MRI?
Yeah. That's that is going to be important. Certainly the package label from the FDA actually has specified the need for that safety monitoring. So the VA has already stepped forward, not just approved the drug, but approved that safety monitoring that goes with it. The expectation is that the FDA and Medicare are going to move lecanemab through, potentially donanemab if the phase 3 results are positive. The issue of copay, though, is a real issue. And we cannot have, there are already, people right now can get lecanemab and aducanumab if they want to pay out of pocket. Yeah. So we have a couple dozen rich people in this country receiving medicines for Alzheimer's that the rest of us can't have. And that's not fair. We need to fix that. We need universal coverage for dementia.
Yay! That's what we're trying to fix in DC. So that's exciting to hear you say that. And that's the truth, that it depends if you have the money at this point. So, all right. So Jenny Sullivan, if the brain is already decreased in size, how effective is the current medications? Will these medications work?
So I think I think we have yet to understand this, but you're alluding to something that I talked about earlier, is that when we wait too late in the disease, there's too much damage that's been done. There's too much else going on. We're going to see diminished returns. And so still the onus, the impetus on us as a field is to really get out there with with our wellness examinations, really probe into memory, really identify people very early on, get that amyloid out of their brains right away before any damage starts. And maybe we have a better chance. Maybe we'll see prevention start to emerge, delay the disease by 10 years. That is a vision of the future I would embrace.
That kind of is what Dana Davidson was saying. If there's no clinical symptoms, how do we catch it early? So mandatory MOCAs or assessments, that's part of the Medicare annual wellness visits, but how can we make people do these things? So there's a lot to learn, a lot to be said. And Justin and Barbara both said, thank you so much. Great session. So Dr. Jicha, we really, really appreciate you being holistic. You see it from all sides, and you have great insight. So definitely everybody that wants to learn more, join the breakout session at 1:30 with Dr. Jicha, and he'll tell you some more about this. I just want to kind of go over some housekeeping. Just wanted to say, I hope everybody's enjoying our second general session. Remember to complete the survey after each session, especially if you need CEU credits. If you have been provided a personalized link that you'll use throughout the conference to complete your evaluation for each session and the conference as a whole. That was sent to you in your email, so please check your email. Also, the OAC Optimal Aging Conference session survey must be completed after each session, including the last session of each day, in order to receive your CEUs. So don't forget to go to the exhibit hall to learn more about our sponsors and exhibitors and thank them for their support. And you can learn about many conference activities by checking out the Navigator bar in the conference foyer. Also, don't forget to participate in the scavenger hunt for the exhibition hall. You will win some really nice prizes. And up next, we have a networking opportunity until 1:25 p.m. To join a networking room, find the one that interests you and select join. Enjoy the conversation with experts in the field. I'll be leading one on health policy. Dr. Anna Fall will be leading one on lifestyle medicine, and Dr. Sam Cotton on Alzheimer's disease and related dementias. So we'll let everybody go to the breakout sessions or go to the exhibit hall, and then we'll see you back. Thank you all.